3 possibilities, right? And so, and when x equal to 1, the probability is 6, 1 over 6, so it will be what? 1, that's the value of x times what? Corresponding probability, which is what? 1 over 6. And then plus 2, that's the second realization, times corresponding probability, which is what? 1 over 2, plus 3, 1 over what? 1 over 3. Okay? And this will be equal to what? 1, 1, 2 should be 6, 13, right? Okay, and this will be the average value for this random variable. Okay, and you can see here, larger probability means larger weight, right, in this average operation. If every value has the same probability, this will become what? 1 plus 2 plus 3 over 3. That's the common average, right? So you can see here. The common average can be interpreted as a mean value calculation when each element has same probability. Okay, for example, if you have, let's say, 10 points, you would have sum of these 10 points over 10, right? So 1 over 10 can be interpreted as what? The probability associated with each element. And here, because each element has different probability, in other words, the weights will be different. Yes. Okay? Second example is about the continuous one, the Roulet example, right? 1, when x is between 0 and 1, and 0 otherwise. Okay? So basically, we would end up touch on any value between 0 and 1, right? Without any calculation, based on our common sense, what should be the average value in this experiment for Roulet experiment? So basically, the change should be even, right, between 0 and 1. Could be anywhere, uniformly between 0 and 1, right? It should be what? The average should be what?
Probability of any.
No, we don't care probability, just use our common sense. It should be where?
The middle?
Right, the middle, half. In other words, the half will be our mean value of this random variable. That's verified from using mathematical calculation. So that for the continuous here, the EX will be actually x fx x dx. And this is kind of like translation from discrete case to what? To continuous case. You can see here, value times probability, right? And the probability here, it's what? Density function here. Okay, minus infinity. But in our case, because this density is from 0 to 1, so we have 0 to 1, right? And also density is what? Is 1 in this range, so it's x here. Okay, so it will be half x squared from 0 to 1, right? It should be what? Half 1 squared minus 0 squared. So that's the mean value in this case, right? Okay, so that's how we can determine the mean value for both discrete and continuous random variables. Okay. Yes.
I probably missed when you defined what mean value was. That's the average of,
That's average,
of your
right.
probability, or if it's your
You
average
can call this weighted average.
weighted
Okay,
average.
because like say in this you can see here, 1 to 3 are 3 possible values, right?
Mhm.
We multiply the corresponding probability. So those probability
Mhm.
values
Are
will
weighted.
function as the weights in this average operation. If all the probability is equal to 1 over 3, then this is what? 1 plus 2 plus 3 over 3. That's what I mentioned, you know. The common average operation can be interpreted as a situation
Where all of them are
where
weighted.
all probability are equal. Okay?
Okay.
And here, when they have different properties, then it just happen to be a weighted average operation.
Okay.
Okay? And then continuous case is just what? Integral will be x times density function. Okay, integral like this. Okay? And for the variance, so it will be something like this. It will be the mean value. So basically it's about, like say, how far away from the mean value, right? And the mean value, like the distance, location could be on both sides. Okay? So that's why we are going to determine the mean value of this distance with what? X minus what? The mean value squared. Okay? So this will give us a distance between random variable and its mean value, right? And because X would take on different realizations, right? That's why, again, we have to take this average. And this average will give us this variance. In other words, how those random variables are distributed around this mean value. Okay? And here, actually, I just mentioned, this E can be treated as an operation. Okay? And also, this actually is a linear operation. In other words, if you have something like this, E, say, A1 x1 plus A2 x2, blah, 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 until An xn. A linear combination of a bunch of random variables, then
Just the
it will be
addition of
equal to
all
what? A1 E x1 plus what? A2 E x2, blah, 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 until what? An E xn. And this is what? The linear property, like exact same as linear property we came across in what? In both 350 and 351, right? So in other words, this E can be treated as such a linear operator. And now, this is the definition, right? And let's just expand this multiplication. So in other words, E x minus x mean value here. And also, I'd like to point out, this guy here, the mean value should be what? Should be a constant, right? It's not random anymore. It's deterministic.
Mm-hmm.
Okay? For example, here in this case, the mean is what? 13/6. It's a fixed. It's a constant. It's not random. Okay, keep in mind here. That's the reason why here you can see here, A1, A2, An are just constant coefficients. They are not random. That's the reason why they can be taken out of this E operation here. All right? Because there's no variation in those coefficients. In this case, expand this multiplication here. Ex squared minus what? 2x x mean value plus what? Mean value squared. Okay? And now we're ready to apply this property here, linear property. So this gives us what? E
To the x
squared minus what? E 2x x mean value plus
Did you
what?
plot the 2?
E x squared,
Squared.
right? Okay, and here I just mentioned, this guy is what?
So constant.
This guy is constant. 2 times this guy is what? Constant.
Two constant.
So it can be taken out. Minus what?
2
2x
x
mean
bar.
value times what? Ex, right? Okay, and here, the mean value of a constant should equal to what? Itself,
Constant.
right? So, because this is constant, that's why equal to what? Plus x squared. Does that make sense? Okay. And here, this is what? Ex is what?
It's just constant.
Mean value. And this whole thing is what? Is mean value squared, right? We then have what? Minus Ex squared minus 2 mean square, okay, plus what? Mean square, and then equal to what? The mean value of x squared minus what?
Mean
The
values.
square of the mean.
Yeah.
And this will be more common used, okay, in order to determine this variance. So it's what? E x squared minus what? The square of the mean. Okay? And this formula is more practical than the original definition. Okay? And then let's see how we can determine the variance for this guy and that guy respectively. Okay? For the discrete case, you can see here, we only need to determine this one here, right? Because this is already derived, which is here. Okay? So let me work here. For this guy here, let's determine EX squared. And here, before we talk about, like say, how to determine this guy here, I'd like to point out a very useful formula. So basically, if we have, say, x is given, right, and then we define a new random variable gx, and in the first half, we talk about how to determine the corresponding density function for y, right? And also here, based on definition, it looks like in order to determine mean, we have to know its PMF or density function. But here, in order to determine, say, EGX, we don't need to actually derive the density function y first. Instead, we can directly calculate this. Gx, fx, dx. Okay? And this is the continuous case, right?
Mm-hmm.
For discrete, will be summation, say gx, and the probability x equal to, say, xk belong to the sample space. You see, if we compare, like, say, mean calculation, for example, here, the difference is what? Originally is x, right? And here is what? Oh, there's a typo here. It should be xk here. Xk, and here is what? Gxk. That's the only difference. This can be treated as what? Identity function. Y equal to x. Here. Okay? And here, this is Gxk. Now, go back to this example here. This gives us what? X squared. And here, x has 3 realizations, right? We have what? 1 squared times the corresponding what? Probability, which is what? 1/6 plus 2 squared probability plus 3 squared 1/3. So this gives us 1/6 plus this is what? 2 plus what?
3.
3, 6 of what? 31, right? Does that make sense? Okay? And then from here, the variance of this discrete random variable equal to what? EX squared minus what? The square of the mean. This is given here. Okay? And then minus what? The square of the mean. The square is what? This guy here.
18. So 13.
13/6 squared, right?
Oh, squared.
And this will be equal to 6 squared. This will be 31 times 6, 186 minus what? 13 times 13,
169. 69?
Yes, hold on, 39, right, 169. So it should be what? 36, and here this is what? 17, right? Yeah, 17. Okay, so this will be variance. Again, you see here the variance should be always what? Always positive, right? If it's negative, then something wrong with your calculation.
That just shows the distance between the.
Right,
decks.
right. Like say, the variance. Like say, if we have larger variance, then or something like this, right? Smaller variance would like this.
Hmm.
Okay, and we are going to demonstrate this again when we talk about Gaussian distribution. Okay. All right. So, okay, this is for discrete, right? How about for the continuous one here? For this one here, we already have the mean value given here, right? And then we need to determine EX squared. Okay. So in this case, we have to use this approach, right? So integration from minus infinity to infinity x squared EX. Keep in mind here, this is what? Realization, gx, okay? And in our case, the limits from 0 to 1, right?
Mm-hmm.
So x squared, this is what?
1.
1. Ex become what? X cubed over 3, 0, 1, equal to what?
1/3.
1 over 3. Okay? And then the variance equal to what? EX squared minus square of the mean. So 1 over 3 minus what? 1 over 2 squared, right? So it will be equal to what? 1 over 12. So this will be variance. Okay? For this random variable. Okay? Okay, usually you see here, whenever we talk about a distribution, we basically have to know two basic parameters, like say mean value and the variance. Okay? Especially later when we talk about Gaussian distribution, this Gaussian distribution actually is defined using what? Both mean value and the variance. Okay? All right, probably, yeah, that's pretty much what I talk about today. All right, because this one is not included, in the current homework. We are going to work on mean value, variance, in the next week's homework.